Hello everyone, welcome to my YouTube channel. So today we are going to discuss the most important algorithm, which is sorting algorithm. Okay, so now what is sorting algorithm? Suppose you are given an array 3, 5, 1, 2, 8, 10, 7. Okay, now you very well know that it is not sorted. Okay, so in this video we are going to see the first sorting algorithm, which is bubble sort. Okay, bubble sort algorithm. Okay, so now what is bubble sort algorithm and how to sort this array using bubble sort? Bubble sort uses swapping technique. If you don't know how to swap the elements, then let me clear you. First, you need to know using if you need to sort the array using bubble sort, then you must need to know what is swapping and how to swap two elements in an array. Okay, suppose you need to swap these two elements 8 and 10. Okay, and the indexes are 0, 1, 2, 3, 4, 5. Okay, so you need to swap the elements which is present at 4 and 5. Okay, so prerequisites. Okay, you need to know, should know, swap two elements. Okay, so this is the prerequisite you should know, you need to know. Okay, so now how to swap it? See, int temp equals arr of 4, arr of 4 which is equals arr of 5, and arr of 5 which is equals temp. Okay, what I have done here? I have done here that, see, first I am storing the element which is present at arr of 4, that is 8, into a temp variable. Temp equals 8. Okay, why? Because I need to use this index. Okay, so this line executed. Fine. Now this line arr of 4 is equals arr of 5. That means I am updating the element which is present at arr of 4th, which is present at 4th index, to the element which is present at 5th index. Okay, so after this line, my updated array becomes 3, 5, 1, 2, 10, 10, 7. Okay, why? Because I'm storing the element which is present at arr of 5 in the index of 4. Okay, so I haven't changed the element which is present at arr of 5. Okay, I'm just updating the element which is present at index number 4 to 10 using this equation. Okay, so it becomes 10 and it is 10 only. Fine. And finally, I'm storing I'm updating the value which is present at arr of 5, that is this value, to the temp. What is the temp? 8. Okay, so now after executing this line, the updated array is 3, 5, 1, 2, 10, 8, 7. Okay, so initially 8, 10, 8 present at 4 and 10 at 5. Now at the end, after we'll swap 10 present at 4 and 8 present at 5. Okay, so we have successfully swapped the elements. Okay, so this is what the swapping technique is. I hope you'll get a clear-cut understanding of how to swap two elements. Okay, so this is the technique we need to use in bubble sort algorithm. Okay, now how this technique we will use? Let's see it. Okay, so now let me take this array into the next page. This is what we got. Okay, so we have learned what is swapping. Now our target, that is how to sort the array using bubble sort. Okay, so we are using swapping technique. In the brief, see, initially I'll tell you in the brief, this is our indices 0, 1, 2, 3, 4, 5, 6. Okay, fine. Now we will check that is this element is greater or less than the previous element. Listen carefully. First case, we will check that is this element is greater or less than previous element. This element is greater. If this element is greater, then we should not swap. Okay, fine. There is no need of swap. Move to the next element. If this element is greater, no, it is less than. If the element is less than the previous element, okay, then swap it. Swap it. So the updated array is, okay, 3, 1, 5, 2, 8, 10 and 7. Okay, this is the updated array. 1 and 5 got swapped. Okay, fine. Now move to next. If this element, we are at here, okay, initially, now we need to move here. So if this element is greater or less than previous element, what is the previous? 5. Okay, so this is less than. If it is less than, if the element is less than previous element, then swap. Conclusion 1. Okay, so this is the conclusion 1. Fine. Now we are at on 2. So 2 is less than the previous element. Okay, so again swap. Second swap. Okay, second case, second swap is better. Okay, so the updated array will be 3, 1, 2, 5 as they got swapped, 8, 10, 7. Okay, now initially the control is here, now here. Okay, on 8. Now is these two element, if this element is greater or less than the previous element, the element is greater. If the element is less than previous, the element is greater than previous, no need of swap. Okay, the control moves here, initially here, then in this case there no need of swap. Okay, so it moves here, so after it got swapped. Okay, then control comes here, so after it again got swapped, then control comes here, so there is no need of swap, so control goes here. Now if this element is greater or less than, it is greater only, so no need of swap, control comes here. Okay, this element is greater or less than previous. Okay, it is less than previous, so swap it. Okay, 3, 1, 2, 5, 8, 7 and 10. Okay, we have swapped it. Fine, so we have swapped it. So what we have done is okay, first we will check element from first index. The element which is present at first index, is it greater or less than? Is it less than previous index? No. If it is not less than, then no need of swap. Okay, again move the pointer to the second index. If this is less than to the previous index, yes, swap it. Okay, so we got this. Now pointer move to 2. If this is less than the previous index, yes, again swap it. So this we got. Now pointer move to 8. If this is less than previous index, no. So just no need of swap, just move the pointer. If this is less than, no need of swap, just move the pointer. If this is less than, yes, swap it. Okay, so what the conclusion we'll get here? From this we got that largest element, okay, comes to its correct position 10. Fine, 10. Okay, if we'll see the final answer will be sorted 1, 2, 3, 5, 7, 8 and 10. Okay, so this is only the sorted version of the array, and this is only what we want. So you can see 10 is present at last, definitely, because it is sorted. So it is sorted in increasing order. So definitely it increasing, and the largest element present at the last index. See here. That means in the first round, of swapping, one element, that is largest element, comes to its correct position. So how many round we need to apply this swapping technique? N minus 1. What is n? N is a length. And how? Now you'll be asking that, hey Yash, how you are just so confident? Let's see. Okay, we will see step by step. Fine, there is no hurry, we will see step by step. Okay, so now let's see in a more detailed way. Okay, in a more detailed way. Fine, how we will implement this technique in a code. Okay, when we write the code in our Eclipse. Okay, so I hope you get to know that, okay, what we are doing it and how we are doing it, what we are doing it and why we are doing it. Now in actual, how we are going to do it and how we are going to implement this, we will see it complete from scratch to end. Okay, and I hope and I assure you that you will get a clear cut understanding over bubble sort. Okay, so let's do it. First, let's take an array. Okay, so the array is, let's take 3, 1, 5, 7, 2. Okay, fine. Now let's take two pointer I and j. I equals 0 and j equals 1. Okay, I'll explain everything that why we have taken the two pointer and why we have taken I 0 and j 1. Why not j 0? Okay, completely I'll explain. Okay, first let's achieve it. Let's achieve the result. What is the result? Sorted array. Okay, it is not sorted. Okay, now according to the formula, according to the rule, if the element is less than the previous element, then swap. Okay, this is the rule. Fine. So and we need to start from the first index. This also I told you. So in the from the first index, if this is less than previous element, if this is less than, yes, it is less than, so swap it. 1, 3, 5, 7, 2. Okay, swap, and I is this and j plus plus. Okay. Okay, now j is at 5. Okay, so if the element which is present at j is less than the element which is present at j minus 1, what is j minus 1? That is only previous element, right? So if this is less than this, no need of swap, just directly j plus plus. If this is less than previous element, no. If not, then no need of swap, just if this is less than, yes, so swap it. 1, 3, 5, 7. You need to swap, right? 3, 5, 2, 7. Okay, so this is what we got, the final array. Okay, and now j is here, I is here. Fine. So this is what we got after first round. This is what first round. Okay, what we got? To the correct position. Okay, second round. Second round. Okay, so what is second round? I plus plus. Initially I 0, I equals 1. Okay, and j start from 1 only. Fine. 1, 3, 5, 2, and 7. This is the updated array. I comes here and j is also here. Okay, don't worry, I'll explain everything, that what we are doing it and how we are doing it. What is a, I, and j, and how we will take this pointer. Okay, in the coding way, how we'll implement it. Just I'll explain you. Just first assume it and then understand the concept, that how we will sorting the element, how we will sorting the array. Okay, so now initially we have taken I is 0 and j is 1. Then after first round we will just incrementing I. Okay, and then again start from j equals 1. Okay, and then traversing till end. Okay, Fine. So again check if j is less than previous element. No, j is greater, right? Okay, so j plus plus. If j is less than, no, j is greater, 5 is greater. Okay, so j plus plus. If 2 is less than, yes, swap it. 1, 3, 2, 5, and 7. Okay, now I is here, now j comes to here. So j comes here. Now it is less than, no. Okay, j comes at the end index. Fine. Okay, so this is what we got the final conclusion, and you can see now the two elements are at correct position. Okay, two elements are at correct position. Fine. Third round. Okay, third round. Third round. ARR 13257. This is what updated array, last updated array. 13257. Okay. Now I again becomes I plus plus. So I equals 2. Okay. And yeah, we start j equals 1. So now I here and j is this. Okay, again check is 3 is less than, no. If 2 is less than, yes, is 2 is less than. So again swap 1, 2, 3, 5, 7. Okay, so j is here initially. 3 is less than 1. Okay, no, then j plus plus. Okay, j comes here at ith position. If 2 is less than, yes, so after swap j again comes here to j here. If 5 is less than 3, no. If 7 is, no, so j comes here. Now if 7 is less than, no. So this is our final. So you can see all three, last three at correct position. Okay, fourth round. Fourth round. Updated array was 1, 2, 3, 5, 7. I equals I plus plus, which is equals 3. Okay, 2, 0, 1, 2, 3. This is I and j. Okay, now check if j is less than previous, no. Okay, j moves here. If j is less than previous, no, j moves here. If j is less than previous, no, j moves here. If j is less than previous, no, j moves here. Okay, fine. This is what the last four index got correct position. Okay, now fifth round. Fifth round. Okay, what the array updated? ARR equals 1, 2, 3, 5, 7. Okay, and I equals I plus plus, which is equals 4. Initially 3, 4. Now 0, 1, 2, 3, 4. I is here, j is here. Okay, again check. Again check j is less than previous, no. J moves here, j is less than previous, no. J moves here, j is less than previous, no. J moves here, j is less than previous, no. J moves here. So this is the array we got, and all the elements are at correct position. This is what we got. 1, 2, 3, 5, 7. Sorted. Sorted, right? Initially, what the array we have taken? 3, 1, 5, 7, 2. And what we got? 1, 2, 3, 5, 7. Okay. So this is what bubble sort is. Now, this is what we have seen that, okay, this is the backend process and overall. Fine. Now, how to achieve this I and j relation, and then after one round, we need to increment. Now, listen carefully. This is the most critical point of this video, that how we need to implement this functionality. Okay, and what we'll use. Fine, and where we need to stop the control. Okay, so let's see it. Now I want you to observe one thing. One round. Okay, we are traversing from a specific element to the last element, and how to achieve it. Okay, so I'm saying it as Okay, 31572. Initially the array we have taken as, okay, initially the array we have taken is, array is 31572. Okay, fine. And initially I is 0 and j is 1. Now we are traversing j from a specific index to the last index, from 1 to last. We are traversing first j coming here, then j here, then j here, then j here, after checking some condition. So how to achieve it? For loop in j equals 1 and till the end condition, then j plus plus. Correct? Yeah, correct, right? Let me write it on the below. So how to achieve it? Using for loop j equals 1, j less than some condition, and j plus plus. And we'll write here the logic of checking that if it is less than previous and then swapping. Okay, so this is the logic, business logic. So this is what we can achieve, traversing j from a 1 to n index. Okay, see, traversing j from 1 to n, again j 1 to n, okay, again j 1 to n, 1 to n, 1 to n. Okay, so how we can achieve it? We can achieve using for loop. So this is the inner rounds, what we are checking, first round, second round. Okay, fine, 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 fine. This is what you know. Okay, after completing first round, after when the j reaches on the last element, we are incrementing I plus plus. So how we will achieve this? That okay, once I is 0, initially I is 0 and j is 1. So once the j for loop ends, we will incrementing I. Okay, and then let j will check again. And then after j will complete the checking, we'll again increment I. How to achieve it? If we have another for loop outside the for loop, outside j for loop, let j will complete its first round, second round, third round, and after it completes, the control moves here, I increment, and then let again j check, again complete, I increment, again j check. So this is clear that okay, we need to use nested for loop. Now what the third thing is? Third thing is the end condition. What should be the end condition? What should be the end condition? So we will now see the end condition. What is this? Is the end condition. Okay, are you getting interest? मजा आ रहा है ना? Okay, fine. So the end condition is I is traversing from, initially I is 0. I is traversing from 0 to n minus 1. See, I is in 0. And what will be the our last I? 4. What is the n? 1, 2, 3, 4, 5. Okay, so we'll get to know that okay, I should traverse from I is 0 to n minus 1. The twist is j. This is the I start and end condition. Okay, now for j. J we will know that okay, the start index of j is 1. Now can I write j traverse from j1 to length minus 1? Length is n only. Okay, this is length. Array length. Length minus 1. Sorry, length minus I. Length minus I. How? Let me write here. Okay, so J condition is J equals 1, 2, J less than length minus I. How? See, J traverses from 1. This is you know very well. Okay. Now, after first round, listen carefully. After first round, one position, seventh is at correct position. Okay. When J is here, J traverses here, here, here. So 7 come at correct position. Fine. Okay, initially we have checked this complete array. Okay. This J is less than previous, then this, then this, then this. Okay, this complete array we have checked. Now, as we know that it is in the correct position. So is there any need to check this complete, or we can only check this area, this part of array 352? Getting my point? See here. In this case, in the second round, I is 1 and J is 1. So we'll check, okay, 3 is less than 3 is less than previous? No. 5 is less than 3? No. 2 is less than 5? Yes. So we'll swap it over the program, over the inner loop. There's no need of checking 7 because it is already in the correct position. So why there is a need of to check 7? So that is why we are putting our end condition as length minus I. So in the after first round, see this is the first round. J equal 1 and J equals length minus less than length minus I. What is I? Initially I is 0, yeah? Right? I is 0. So put J less than, what is the length? 5 minus 0, which is 5 only. Okay. So J should traverse from 1 to 4. It is less than 5. Okay. It is less than 5. That means it should travel till 4 only. Get a point? Initially J is 1. Okay. J will traverse when I is 0. So J will traverse from 1 to 4. 1, 2, 3, 4. Okay. So that covers complete array. Next, when I becomes 1. So J should less than length minus 1, which is 1 because I is 1. Okay. So what is length? 5 minus 1, which is 4. So J should traverse less than 4, means 1, 2, 3. Okay, when I equals 1. Okay. So when I equals 1, in this case, when I equals 1, so J from 1 to 3. 1, 2, 3. 0, 1, 2, 3. This is what? That is what we want. Okay, because we need not to check the last element. That means we need that J should traverse till 1, 2, and 3 only. Okay, because last is already in the correct position. I'm explaining this again and again. It is very important. Okay, when the I becomes 2, I becomes 2. Okay, so when I becomes 2, then 5 minus 2, that is 3. Okay, so J should traverse till J less than 3. That means till 2. So J is here. So 0, 1, and 2. Only this condition it should check. That it is less than, then swap it. These two are already in the correct position. So the best condition for J is J1 and less than length minus I. And then apply this. So the final code I equals 0, I less than n minus 1, that is length minus 1. Length minus 1. Okay. ARR dot length minus 1 I plus plus for int j, write int here. Okay. J1, J less than ARR dot length minus I, J plus plus. If ARR of J is less than ARR of J minus 1, that is previous element, then swap J to J minus 1. Okay. What is the swapping? Okay, how to swap? Int temp equals ARR of j. ARR of j equals ARR of j minus 1. ARR of j minus 1 equals temp. Okay. And then loop ends. Okay. Just over the program. And finally, you got the sorted array as your answer. So you very well know. Okay. Okay. So now we'll see time and space complexity. Okay. As you already know that in linear search, in binary search, we have seen time and space complexity, which is very important for interview purpose. Okay. So now let's see first time complexity. It is really important in it. Okay. So what is time complexity? So okay, suppose array is given to us as 3, 1, 7, 2, 5. Okay. And in time complexity, we have already discussed. If you don't know what is time space complexity, then I have briefly discussed in the past videos, previous videos, linear search, binary search, and I'm also going to publish time space complexity dedicated video of 2 hours. Okay, in which we will gonna solve the recurring relations and all the programs of FAANG interviews which they target. Okay, so time complexity. So as we already know that, and as we already discussed, study that time complexity means how my time grows as my input grows. Okay, and also when we talk about time complexity, we will always see best and worst case. Okay, best case and worst case. So what is the best case? Best time complexity is O of n, and worst time complexity is O of n square. How? That is what? How? And we will derive it. Okay, don't worry, I'll not leave anything, we will derive it. See here, two loops we are using. Okay, so first let's see the best case. Best case. Okay, suppose our array will be 1, 2, 3, 4, 5. Okay, suppose this will be our array. I is 0 and j is 1. Okay, now you will apply bubble sort. You will apply bubble sort. Bubble sort. Okay, and while applying bubble sort, j is not been swapped. Okay, j is not been swapped at least once. Listen carefully. You apply bubble sort. Okay, you'll check, is 2 is less than previous? No. J comes here. Is 3 is less than previous? No. J comes here. Is 4 is less than previous? No. J comes here. Is 5 is less than previous? No. J is here, and then loop ends. Important conclusion. If J has not been swapped at least once, then the array is sorted. That means, and the loop. Most important conclusion. Okay, we have seen that okay, J has not been swapped, so we'll end the loop. But how the best case time complexity O of n? Okay, how? See here. If I'll tell you that each iteration takes 1 second of time. Each iteration takes 1 second of time. Okay. So how much time it takes to just end this program in the best case? If this is the array, okay. J checks that 2 less than 1, then J checks, okay, this pair, then this pair, then this pair, and then loop ends. So how much time? Checking this, checking this, checking this, checking this. 4 times n minus 1. Okay, n minus 1. So it is taking, in the best case, if the array is sorted, in the best case also it is taking n minus 1 time. Okay, as in the time complexity we will ignore the constant, okay, because the more dominating term is n. Okay, so what we'll get the conclusion that in the best case, if the array is sorted, sorted array given to us, then also at least minimum to minimum, we will take around n time. Okay, so what will be the time complexity? Best case is O of n. Getting a point? O of n. Because, okay, the array is sorted, but j has to traverse once, at least once, and to traverse one. If the array is, see, if the array is the length 5, if the array is of length n, okay, I am taking out the general case. If the array of length n, then it should traverse n minus 1. Okay, here n is 5, n is 1, 2, 3, 400, 200, 1 billion, 1, 2 billion. So what is the general case? O of n. It is the best case in this case when the array is sorted. So it should traverse at least once. Okay, and how once? Because if the j will not swapped, then we will check. Okay, j has not been swapped at least once according to this rule. So we'll end this loop. And how to implement this functionality? We will declare an boolean is swapped equals false. Okay, initialize here. Swapped is swapped equals false. Okay, inside it, make is swapped equals true. Okay, if the array is sorted, then it will not execute this condition. Okay, AR of j is less than. No, it will not execute this condition. If it will not execute this condition, then when it comes to this for loop, we'll again checking if is swapped is false. That is swapped is false, which is true. Break. That means loop ends. So how much time? How many time it execute? N times. Okay, because the inner for loop is executed at least once. At least one round we have done. Getting my point? What is the best case? If you'll not get this, then I don't know. No one will able to understand. Okay, so this is what best case. Now let's see the worst case. Worst case. Okay, if the array is given to us like this: 5, 4, 3, 2, 1, and we want 1, 2, 3, 4, 5. Then see, we'll use this for loop. Okay, for I, we'll use again for loop. For j, now see, I is here, j is here. Now j will traverse n times. Okay, because okay, for the first round, this largest element come here. Then second round, it will come here. Then it will come here. It will come here. So for first round, j will traverse n minus 1. Okay, then j will traverse n minus 2. Then j will traverse n minus 3. Then j will traverse n minus 4, and then n minus n, and then till 1 0. Okay, so it is traversing n. See, j is traversing n times, and I also traversing no. After j got traverse n time, n minus 1 times. Again move here, I plus plus. Okay, so I also traversing n times, right? Okay, so if we will ignore the constant, so it is also executing traversing n times, and it is also traversing n times. So it is n into n. Okay, how we will drive it? Don't worry, we will drive it. So if this is the array, then initially it traverses n minus 1 time, then n minus 2 time, then n minus 3 time, then n minus 4 time. Okay, n minus 1, 2, 3, 4. Fine. Function of n. Let's solve this. N, 4n minus 1 plus 2 plus 3 plus 4. Okay, 4n, and what is the value of this? Okay, what is the value? 1 plus 2 plus 3 plus 4 plus n into n minus 1 upon 2. Okay, this is the relation. This is the relation of this progression. So n into n minus 1 upon 2. Okay, if we solve it, then what is the 8n minus n square minus n upon 2? Okay, so what will be the output? 4n minus n square upon 2 minus n by 2. Okay, this is the more dominating term, n square, because if the n is 100, then this is incrementing square times 10,000, and it is 100 upon 2, and it is 4 into 100. So it is 10,000, and it is very less dominating. In front of n square, they are nothing. That's why we can neglect it in time complexity, and overall is a function of n square, so that we can write it is n square time complexity. Getting what I have told you right now? We have proved it. Getting? We have already proved it. Fine. Okay. So this is what the space and time complexity. Fine. Now the next thing is the stability. The one last topic is remaining is stability. So what the stability is? Stability means, suppose array is given to us, array is given to you, 10, 20, 10, 20, 10, 30, 10. So after sorting 10, 10, 10, 20, and 30. Listen carefully. It is another good topic. So I'm just trying you to explain that it is not stable. Not stable. See, overall stability means it's a very small topic. Stability means, see, if there are more elements present, if there are more same element present, same value elements. See, in this array, 10 is present at 3 times, but after sorting, the 10 which is a black color comes first, but it is not following the actual order. In the actual order, the blue color 10 first come first, okay, then 10 red color, and then red color, black color. So stable will be 10, 10, 10, 20, and then 30. This is the stable, okay, because it is following the actual order, but it is not following the actual order. Okay, so this is what it's a small topic, but I feel like it is important to, because it's my promise that we will not leave anything. So that is what is stable and non-stable. Okay. Now the last thing is, let's code. Let's code. Okay. So let me open my Eclipse. Okay. So let's create a new project. Sorting. In this we will kept bubble sorting and merge sort, also sort. Fine. So let's create a class. Packages com dot sorting. Okay. Class is bubble sort. Okay. It is created. First main method, it is created, then get me sorted array. Let's pass the array. Okay. Let's create the array first. ARR is 3, 5, 1, no, 6, 7, and then 1, and then 0. Mm. Let's create this method, static void. We don't want to return anything. Okay, let's return. Fine. Int ARR. Now, what we have discussed? We have discussed this thing. Okay, let's implement exact. Let's implement exact for int I equals 0, I less than ARR dot length minus 1. See, same thing we are implementing ARR length minus 1. Not the there is different, here is different. No. Okay. For int j equals 1, j less than ARR dot length minus I, j plus plus. See, same thing. Length minus I, j plus plus. Then condition. If ARR of j is less than ARR of j minus 1, so swap it. Okay. Okay. How to swap? Int temp equals ARR of j. ARR of j equals ARR of j minus 1. ARR of j minus 1 equals temp. Okay, fine. Return ARR. Let's print system.out.print arrays dot to string. Why? Because we are printing the array. So if we'll not use array dot to string, then it will give me the hash code value. We have already discussed how to read hash code value of 1D array, 2D array. Okay, done. Can we run it? Can I run? 356710. Server Java application 013567 sorted. Okay, so here when we debug it, the main thing when we debug it, okay, yeah, the control stops here. Okay, I0 J1 AR of J is less than AR of J minus 1. That means 5 is less than 3. No, fine. J plus plus. J equals, now J is 1. So now J equals 2. Okay, if 2 is less than, that is 2 minus 1. Means if 6 is less than 5, no. If 7 is less than 6, no. If 1 is less than 7, yes. Condition true. It comes here. So J is 4. 0, 1, 2, 3, 4. 4 is less than 7. Means AR of 4, that is 1 is less than 7. Okay, it swapped. What is the array? Over on the array. 35617. See, 35617. And what is the main array? 35671. So it got swapped. Fine. Again, now J is 5, 0, 1, 2, 3, 4, 5 means at the last index. So what is the array? J is here. You can see 5. J is here. Now is ARR of J, that is ARR of 5 is less than this? Yes. Again swap. Okay. So what is the array? Updated array 356107. Okay. So it got swapped. So 356170 and the final also got swapped. So the conclusion is the last element, the largest element
got its correct position. Okay, fine. So now we need to check here itself. Okay, we need to check here itself, and then it is checking. So now see j equals 3, 0, 1, 2, 3. Okay, j equals 4. Fine. So it becomes 3510. Okay, because 1 comes here. So now they got swapped, and the new updated array is 351067. Now I want you to show that it will not go again. J is 4. Okay, see, it come outside because we are running from array.length minus I. In this case, I was 1. Okay, so it is not checking the last element. Why? Because this already got sorted. Why we need to check? Okay, we already explained in complete detail in the past minutes we have discussed. So in the same way, it will get executed and this. Okay, the next case 1, comma 2, comma 3, comma 4, comma 5. So in this case, Java application. Okay, and debug it. Okay, it comes here and it is checking that 2 is greater than 1, 2 is less than 1, no. 3 is less than 1, no. 4 is less than 3, no. 5 is less than 4, no. See, 0, 1, 2, 3, 4. ARR of J is now at 5. Can inspect it. 5. Okay. So 5 is less than no. Okay. Now it should end. It should end. What we have seen here. We have seen that if the J has not been swapped at least once, then the array is sorted and end the loop. Are you getting? See, J is not been sorted. J is not been swapped at least once. Then why we need to check in okay, moving I is 1, moving I is 2, moving I is 3, I is 3, I is 4, already sorted. So why we need to add extra iterations, extra time? That is why for that, see here, we have not added any check. Okay, so now see I equals now 1. I equals 1. I equals 1. Okay, now it again checking from j equals 1, that yeah, is it less than, is it less than, is it less than, is it less than, then I equals 2, then I equals 3, I equals 3. Unnecessary iterations, unnecessary time. So what we need to add it, boolean is swapped equals false initially, and if there is a need of swapping, then definitely this condition got true. This condition got true. So is swapped equals true. Okay, once the loop ends, if is swapped, then break. Now let's see. Debug a Java application. Okay, I equals 0, j equals 1. It is checking if ARR of j, that is ARR of 1, 2 is less than previous element. No. See, this condition is not getting true. Okay, until there is a need of swapping. No. 3 also not less than, 4 also not less than. Okay, j is now 4. So it comes here. Okay, means it is not been swapped. That is array is already sorted. Now is swapped, which is false. Okay, it is a not operator. So false is not. That means true. So if false, that means we know that is swapped is false. Okay, so that statement is true. If swapped is false, yes, that statement is true. That statement is true. Then break it. Return ARR. What is the original ARR? And we got it. Okay, so here we have seen this program. Okay, and in this case, when array is sorted, it no need of extra iterations. But why it is off and time complexity? Because if the array is sorted, that means okay, array is sorted, but then also it should traverse once. It should check once that okay, it is less than, it is less than, it is less than. If we got that okay, the array is not been the element has not been swapped at least once, then we will break it. So it is traversing one n times. That is why it is O of n. Okay, we have proved it. And if the array got swapped, then it is O of n square. Okay, so this is what we have seen the code, both cases and the debugging also. Okay, so this is what we have done, bubble sort. Okay, the next thing is another sorting techniques, and then we will complete soon. Okay, we will complete. I'll not delay much. Okay, I know the importance. Okay, so if you like the video, then please comment down, share, subscribe, and thank you.